See this one, this is an important point that you should be remembering. Both A and A transpose will have the same eigenvalues. So what I mean to say is, if you have a matrix A, if you take the transpose of it and if you try to find out the eigenvalues, then both of them will have the same. So like this, for example, if you have a matrix A, B, C, D, and if you try to find out the eigenvalues of this A, B, C, D matrix, or if you try to find out the transpose of it, so what I mean is A, C, B, D, both of them will give the same eigenvalues. So proof is interesting. I'll just use the basics of the algebra, this matrix algebra, to prove it. Just try to follow this one. Now in order to find out the eigenvalues, we are going to use this expression, right, A minus lambda I. So let me take that one and work on it. So if you have A minus lambda I, and if I take the transpose of it, what will be the result? So it is just like A minus B transpose. You must be remembering this. A minus B transpose is equal to A transpose minus B transpose, isn't it? Similarly here, A minus lambda I. A is a matrix and lambda I is a matrix, isn't it? Even though you have two expressions, lambda into I, you can write it as lambda I. So it is nothing but A transpose minus B transpose. Therefore I am writing it as A transpose minus lambda into I transpose. Why am I not applying transpose to lambda? You need not apply it, isn't it? Why? Because lambda into B, let's say B is a matrix, transpose is nothing but lambda into B transpose. That is why lambda into I whole transpose is nothing but lambda into I transpose. Got it? And now we know that I transpose is nothing but I itself. So this entire expression A minus lambda I whole transpose boiled down to A transpose minus lambda into I. Got it? Okay. Now let's try to apply the determinants on both of this. If these are two same matrices, then of course the determinant will be same. That is why the determinant of this matrix is equal to determinant of this matrix. What is it? A minus lambda I transpose is equal to A transpose minus lambda I. I didn't do anything here. I just proven these two are equal, and then I have taken this one and applied the determinant, and so applied the determinant to this. I didn't do anything new here. Okay. And now we know that if this is entirely, if you consider it as a single matrix, and if you are trying to find out the determinant of it, right, we know that A transpose determinant is equal to A. So determinant of A transpose is equal to determinant of A. We already know that, right? Therefore, if you see this one, the determinant of this entire matrix transpose is equal to this matrix determinant itself. Therefore this one can be written simply like this, and I'm not doing anything new here. We already know all these basics, right? Determinant of A transpose is equal to determinant of A. So I'm just replacing it with this one, and right hand side I'm leaving it as same. Now if you observe this, determinant of A minus lambda I is nothing but the characteristic expression in order to find out the eigenvalues of matrix A, and determinant of A transpose minus lambda I is the characteristic expression for finding out the value of eigenvalues of A transpose. Now the equations which are used, or in fact the expressions which are used to find out the eigenvalues of A as well as eigenvalues of A transpose, both are equal. Therefore what can we say from these two equations? That when the equations are same, of course the roots will be same, isn't it? Therefore A and A transpose will have the same eigenvalues. Got it? So from this equation we can say that both A and A transpose will have the same eigenvalues. It is an important result. You should remember this. Otherwise you can derive it, but then deriving it in the exam may not be that simple. Therefore try to remember it, or if you don't remember it, take an example and work it out, then you'll understand it. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs universities better than IITs. They have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.